Abes, so the first thing that we need to go over to get ready for Monday's quiz is SOHCAHTOA. It's understood basically that you have an understanding of this going into the quiz. So I'll write it out here. SOHCAHTOA, and as you know, that refers to sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. So this will become more clear as we apply it. I know that you said that you have an understanding of it. It doesn't hurt to go over it again, just to make sure we have it on lockdown before your quiz. So there it is. Sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. Tangent is equal to opposite over adjacent. And this is always referring to when we have a right triangle. And when we're starting at a certain angle, we'll call it theta for now. The reference angle is always going to be that theta. And then, so when we say opposite or adjacent to, it's referring to opposite or adjacent to that theta angle. We'll get into that more shortly. The next assumption that you understand going into Monday are the two types of main triangles, that is the 30, 60, 90 right triangle and the 45, 45, 90 right triangles. As you know, with the 30, 60, 90, you have your right angle, you have 30, 60, and of course your 90 is right there. Opposite your 30 is where you have your x angle, your hypotenuse is 2x, and opposite your 60-degree angle here is where you have your x root 3. All this will become more clear as we do some very specific examples. Your next right triangle, we'll put it here this way. We'll call it 45, 45, 90. And this is where you have your legs. Both legs are equal because they're both 45-degree angles. They're both x root 2, and your hypotenuse is x. We're going to practice these, and it's understood that you know this going into Monday, and we're going to apply all these things that we just learned, the 45, 45, 90, 30, 60, 90, and SOHCAHTOA. We're going to put it all together for you right here on this unit circle. That's why I have drawn it here for you, and we're going to label it so that you can do some trig functions for your quiz on Monday. Now, the next assumption that you know is that this is a unit circle, right? And we're going to make it really easy and say that this circle has a radius of 1. Right, so this radius is going to be equal to 1. You can see the big circle, and as you know, any line drawn from the center of the circle to any point on the outside is called a radius. So the radius of this unit circle is going to be 1. That makes it really easy for us because now if we want to figure out the special trig functions that we need for this chapter, it makes it very easy because if we draw a right triangle, we make a right triangle from this point, it allows us to say, okay, if this is angle theta, call this angle theta, then your sine of theta, as you know, SOHCAHTOA, I'm going to write it over here, sine of theta is opposite over hypotenuse. In this case, the sine is y. Why is it y? Because, well, we're talking about this height here. This height is y. Right, and this distance isn't really relevant for this problem, but I'm just going to label it because as you can see, we're on the x-axis here. So this line is x, and this height is y. So basically, your sine of theta, so we can put it like this, sine of theta equals opposite over hypotenuse, this is your reference angle, so your sine of theta is y over 1, which is simply y. I just wanted to show you this very simple example because basically now you know that by making a radius of 1 on this unit circle, that's why it's called a unit circle, because the unit is 1. And we have a very simple way of now showing that the sine of theta is equal to y in the unit circle, and the cosine of theta is equal to adjacent over hypotenuse. This is the next problem. Cosine of theta is equal to what? Adjacent over hypotenuse, because in your SOHCAHTOA, the cosine is equal to adjacent over hypotenuse. So now this is your reference angle again. Adjacent to that reference angle is x. So we've got x over the hypotenuse of 1. So it's x over 1, which is simply x. So your cosine of theta is equal to x. Now if we continue and say, let's say that we drew this radius and we know it's equal to 1, and we call this right angle here, we call this theta. Instead of theta, we can see that it's pretty much 45 degrees. The way that I've drawn it, it looks like it's a 45 degree angle. So now, if we know that this is 45 and this is 90, this angle has to be 45. And this angle, if we know the hypotenuse is 1, and we know that in your 45, 45, 90 triangle, you've got x root 2, x root 2, and x is your hypotenuse. Your legs, in this case, must be x root 2 and, which in this case is 1 root 2, so it's simply root 2. Our legs are root 2 and root 2. So your sine of 45 degrees is, let's say in this case, it's going to be your sine of 45 degrees equals, and we're talking about this 45, not the other one, is is opposite over hypotenuse, which is root 2 over 1. So your sine of 45 is simply root 2, and we know that makes sense because your sine of y, remember when this angle was theta, your sine of theta equals y, right? So that's always going to be true, especially in this case where your sine of 45 is still y, because look at what your y is. Your y is root 2. Your y is root 2. I could also go a step further and say your cosine of theta, remember we did this before, your cosine of theta when this was theta was x. This was your x. Now in this case your x is root 2. Let's see if it still holds true. So your cosine of 45 degrees equals adjacent over hypotenuse, right? So it would be root 2 over 1, so that equals root 2. So look, your cosine of 45 is still equal to x. In this case, it's root 2. So we're going to continue to do a little bit more practice. I'm going to show you a 30, 60, 90 triangle now. Now, if you recall, with the 30, 60, 90 triangle, you've got x is the 30 degrees, 2x is the hypotenuse, and x root 3 opposite the 60. So in this case, if your hypotenuse is 2x, your x must be simply opposite the 30, which is 1/2. And then if this is your x, then your opposite your 60 degrees will simply be 1/2 times root 3, because remember this is x is 1/2. We solved for x over here. Basically, we got x is equal to 1/2, and we know that your x is 1/2. So you multiply that by root 3, you get root 3 over 2, opposite your 60. So this is your 30, 60, 90 triangle, labeled correctly on your unit circle. And now let's go up here, and let's say that this is your, since this was 30, then this angle is 30, so now this angle here, call this 60, Right, let me see if I could do this in a different color so it's a little more clear. Right, so this angle, we'll say that this big angle is 60. We'll make this the 30, and make a right angle here. Now, of course, this is still 1. Now, this angle opposite the 30 is going to be your 1/2, and this line opposite the 60 is going to be your √3/2. Now, let me show you that again. You know your 30, 60, 90, right? So we know that the hypotenuse is always going to be 1 in the unit circle. That's a given because that's the radius. And so if that's here, right, if that's going to be here as your 2x, your x is simply 1/2 of the 1. So your x is equal to 1/2, right? So your x is equal to 1/2 in this case. And just as a standard, something you should always memorize is that opposite the 30 is where your x is going to be located. Your hypotenuse is 2x, and your opposite your 60, in this case, this angle is 60. So opposite your 60 in this case is √3/2. Notice in this other 30, 60, 90 triangle, your 30 was in this lower corner here. So your x value and your y value are different in this case. Because you have, yes, they're both 30, 60, 90 triangles, but the 30 is in one place here, and the 60 is in that place here in this triangle. So now we've gone over three different triangles on the unit circle, and we've labeled them. So in this pink one, in the hot pink one, your sine of 60 degrees equals opposite over hypotenuse. So your sine is going to be √3/2. Again, it's always going to be y. Notice that this was the y, sine 3/2. Your cosine of 60 is going to be, of course, your x. So in this case, it's 1/2 adjacent. Cosine is adjacent over hypotenuse, so it's 1/2 over 1. So your cosine of 60 degrees is 1/2. And of course, let's go back to the blue color to finish up this smaller triangle with the 30 here. So your sine of 30 is equal to opposite over hypotenuse, so it would be 1/2. And your cosine of 30 is going to be adjacent over hypotenuse. Adjacent over hypotenuse, which is √3/2. Again, your sine is x, your sine is y, your cosine is x. Still holds true, and it will continue to hold true. And that's important because we're going to continue to practice this tomorrow. We're going to go into more detail.